Okay. So now that we understand kind of how, okay, now that we understand how scientific notation works, we can take a different, a look at um, how we can measure uncertainty. So uncertainty, for example, can be looked at here. Certainty is a way that we can look at this one, right? If I said, how many apples do you see here? You would say there are four apples, right? That is 100% certainty that there are four apples. You got one, two, three, four. All right. And this would be an example of counting. So counting tells you that you have 100% certainty. You don't need any kind of uncertainty. If you can count the number of things, that is going to exactly be a certain value. However, if I were to ask you about this aluminum rod, how long is the rod? You could say it's 4 point maybe 1 centimeter. Maybe it's 4.15 centimeters. Maybe it's 4.1562382 centimeters. But how do you know? How exactly sure are you? Well, this is uncertainty. This is where, as scientists, we can allow a little bit of wiggle room in what we are talking about. And so, if you are unsure of the measurement, we can use significant figures um, to kind of round things out. So, for this one in specific, before we move on, we can talk about the uncertainty of the length of this metal rod by saying the uncertain digit that we are going to add to this, we are going to add one digit past what can be measured. So um, we can measure the ones place of the centimeters, and we're going to take a guess, our educated guess, based on how long it's going to be. So this would end up being 4 point, let's say 2. That's, I think, a fair thing to say, centimeters. But when we're talking about uncertainty, in chemistry, I think specifically, we're going to talk about significant figures. Now, if there's anything I've learned from teaching chemistry, it's that this is the bane of students' existence, but it's also where I get to take the most points from. So that's fine. I get hungry for points just like anybody else. So, significant figures. These are digits that represent the precision of a measured number. Okay, so we cannot say for sure that this measured number could go all the way out to 10 decimal places because the piece of equipment that we are using to measure it does not go to that many decimal places. It goes to 0 decimal places. So we're going to have to guess. We know that it's not exactly on 4, but we don't know exactly where it is. So our uncertain digit is going to be right there. For significant figures, we're doing something very similar. But there's a lot of rules that come with this. And so let's go through them. So when we're looking at the significant figures of a number, our first rule is that all non-zero digits are significant. So if you have a number that is not a zero, this is a significant number. Okay. Significant number means that we are not going to round it away. Like we're going to round a number. We're just, it's going to matter. Um, Sandwich zeros are going to be zeros that are between two non-zero digits. So right here and right here, these are our two sandwich zeros. Those are both significant. Zeros that are after a written decimal point that are after a non-zero number are also significant. So after a written decimal point, after a non-zero number, that is going to be this zero right here. That does matter. After a written decimal point, right there, after a number, those are so This is our significant zero right here. Now, this would be considered an insignificant zero. It is not after a written decimal point. It is not after a number. So it is not significant. Trailing zeros. So after a non-zero number, but before a written decimal point. Now, you see how this is capitalized, written decimal point. That's important. A written decimal point is different than just a decimal point, right? A written decimal point is going to be one that is physically present. And we're going to see that. We actually did see that before, but we can see that there is no written decimal point down here. We're going to get to that in just a second. But written decimal points, trailing zeros. So after a non-zero number, that's our non-zero number right there, and before a written decimal point. So this is our written decimal point, this is our number, this is our significant zero. Okay. These two not only are sandwich zeros, but they are also after a non-zero number and before a decimal point, a written decimal point. Zeros before a non-zero number are not significant. So if there is no number over here, a non-zero number, all of these are not significant zeros. We don't care about them at all. This one right here, not significant. This one is after a written number. This one is a sandwich one. So otherwise, all the zeros are significant, just not that one. Trailing zeros after a non-zero number before non-marked decimal points are not significant. So that means that, and this is, pay special attention to this one. This is the one that gets students every single time. I swear it does every time. All right. Trailing zeros after a non-zero number before non-marked decimal points. So there is only one significant figure in this number. That is the four right there. This zero is not a significant number. This one has two significant figures. I'm going to abbreviate that as SF pretty much from now on. Um, this one does not count as a significant number because there's no decimal point. If you come up with a number, let's say that you get this and you need three significant figures, you will add a decimal point with nothing after it. So it ends up being this 350 dot. That gives you a significant figure, or that gives you a higher number of significant figures. Exact numbers, like the number of apples, or the things that you can count, so counted, uh, we can also call these counted objects, like three pencils and two apples, versus a measured quantity, so something you used equipment to be able to find the number of. Those have different significant figures. Measured quantities are only as accurate as whatever you're using to measure them with. So if we go back real quick to this, a ruler is only as accurate as there are ticks um, that we are measured that we can measure with. Uh, it's different the for counted objects have infinite significant figures. They have as many as you need to complete the calculation. What that means is that it doesn't matter how many significant figures there's going to be. You don't care about it. You're going to just count based on the whatever your measured quantity is. Okay. So when we talk about rounding, there's a couple rules to these. This one's a bit more simple, actually, than rounding is uh, for, or sorry, not cut. What do I do? If I do this, this is what I need to cut. So rules for rounding, this is a bit simpler than the rules for significant figures, right? If we need to round, If the number is less than five, then, so that means if a number ends in zero, one, two, three, four, um, that's it. Zero, one, two, three, or four. You will get rid of that number and make it into a zero. So you're going to round down to zero. So for example, let's say that I had the number 1.02 and I needed to round that last number away. Well, 2 is one of these numbers. It's right here. It's less than 5. It's greater than 0, right? It ends in 2, and I need to just have this have 2 digits in it. When I round that, I'm going to get rid of that, and this will just become a 0. So that ends up being 1.0. That's it. I'm rounding away this 2 to just leave the 0 behind because that 2 is uh, less than 5. If your number is greater than 5, so that's going to, or equal to or greater than 5, it's going to be 5, 6, 7, 8, or 9, then you are going to round up and make that number a 1. So um, that would mean round, or not a 1, but whatever the next number is, round up to next number. So let's say that I had 1.05 instead. This, I would take this 5 and round it up to the next highest number, which would be 1.1 in the same vein. So um, similar. So if I were to round these two numbers to only four significant figures, I'm only going to take the four highest significant figures. For example, we have a one, two, three, four. So I need to trim. That means that I'm going to round this six either up or down. Well, six is part of the round up numbers. So this number ends up being 1.001. And that gives us four significant figures. We have two non-zero numbers and two sandwich numbers. So 1.001. And don't forget your units. You're always going to want to remember your units. For this one, I have to do the same thing. I need one, two, three, four, which means that this is what I'm going to be changing. Since this is a 5 and still rounds up, that's going to fall into the rounding up category, which means that this is going to end up being 1.603. I'm going to round this up to the next highest number. Um, and so that ends up being the next highest number. Now, you might notice that there is a 10 to the 19th. This never gets rounded. We don't ever round that. That's going to stick with it. It's basically just a multiplier. It's just something to multiply that number by to get you the actual number without having to write out all those zeros. So that is going to end up being 10 to the negative 19th joules, which is what that J stands for, is joules. It's a measurement of energy. Okay. And if we wanted to use significant figures in calculations, there's two different ways to do it. So for multiplication and division, there's two different, or yeah, multiplication and division, those are going to use one set of rules. Addition and subtraction are going to use the next set of rules. Multiplication and division, we want to find the one that has the least amount of significant figures. The least amount of significant figures. So that means that we're going to look at these two numbers and which one has fewer significant figures. Well, on top we have four sigfigs. On bottom we have three. These count as significant figures because they are sandwiched between two non-zero numbers. This is a trailing zero after a decimal, so that is that also counts as a significant figure. This one, however, has the smallest number. And so when you do this math, the number you should get out is 1306.52, But we only want the three highest significant figures, which means we're going to take this number and round it up to this. So we'll end up with 131. And I'm going to put a zero there. The reason for that is these three are my significant figures. Since there's no decimal, there's no decimal, that means that there is no that this is not a significant figure. Okay? If I put a decimal there, I no longer have three sig figs. I now have four sig figs. So no decimal. And the three sig figs that I require. The other way that I can write this, if this gets confusing to you, you can always put this into scientific notation. That is what I did before really truly understood how this worked. And so the way to do that is like this. Well, we need to put a one number next to the decimal. That's going to be one. We'll put a decimal, and then we'll put 3, 1. That's the total number of significant figures that we need. We'll multiply this by however many steps it would take to put sorry, however many steps it's going to take the decimal, the invisible, the non-written decimal, and put that between the one and the three, just like it is over here. That's going to be three steps. And so that would be 10 to the third. Okay. 1.31 times 10 to the third is what you end up getting out. Um, and so either way that this is written, either as 1310 with no decimal, or 1.31 times 10 to the third. Either one is totally fine to write. Those mean the same thing, so it's a-okay. Okay, for addition and subtraction, it's a little bit different. And so what we'll do is we're going to find the number that has the result's going to have the same decimal place, decimal count, as the fewest decimal places. So this one 3.2 has the fewest decimal places. What I like to do is I will just draw a line all the way down. Now, what happens when you add all these numbers up is you get the number 13.938. However, 3 and 8, if we're keeping all of these in the same order, are past the line. And so the number we get out at the end is going to be 13.9. And that's it. So we are going to have just those three digits present. So it's kind of a strange way to call it a significant figure. It's tough to say that. But here are two things that you should remember. So um, you are going to, if you have a chain of calculations to do, you're going to do this. Um, always base or always wait until the final calculation to calculate Sigfigs. Always wait till the final one. So we're about to get into some that have multiples. So uh that's where you're going to trim to. The other thing I'd like you to remember is um base your sig figs on original data. So if you measured a number, that's the number you should use at the end. That's the number of sig figs you should use at the end. Okay, so let's try this out. So we'll follow, we're going to follow PEMDAS. So that's parentheses, exponents, multiplication, division, addition, subtraction. Then we will calculate. So parentheses is first, which means we will take this value and convert it to what that is going to be. This number is going to be negative. Uh, we have negative 37.049. So that ends up being negative 37.049. And when we divide that by 0.0087, we get the number negative 4,258.5 up or thereabouts. Now remember, you want to um, you want to base the Sigfigs on the original data. So it looks like this is going to be our original data that we're basing something off of. You also want to wait until the final calculation to calculate Sigfigs. So we don't care how many Sigfigs we get from this first calculation. We are going to um, base it on the lowest, on the last calculation. So the last calculation we do by PEMDAS is going to be a division. And so that is going to be uh, based on this number of significant figures. So our answer is only going to have two sig figs. We will trim this to two sig figs, which means that we are going to use this 5 right here to round that 2 up. And we end up with negative 4,300 with no decimal place. Remember, there's no decimal place if you want two sig figs. If you want two sig figs, no decimal. Um, Following those zeros. You can also write it like with using scientific notations. That's going to be, oh, we got a visitor. Come on, come on. I need to do this. Please go past. Okay. We also have, we can also do this in scientific notation. So we have uh, negative 4.3, Jesus, negative 4.3 times 10 to the third, right? We're going to take this decimal place, put it over there. We have to hop 3 times to make a larger number. And so we end up with the third.